Hello everyone, and welcome back to the channel. This is Sean. This is part 2 of working on the Ibanez TA35 Troubadour amplifier. Now I have removed the upper portion of the amplifier from the chassis. We'll eventually break this board down a little bit more. Now this did turn out to be a solid state amplifier, transistor based amplifier. Several things that we have here. Again, I don't have the schematic, so the component wise I understand the components, but how everything is interconnected, and if you touch something, how's it going to affect the next part of the circuit, I do not understand without a schematic. A schematic is kind of like reading a book. It helps you to determine where you're at and then where you're going to concerning how the circuits components are intertwined in a given circuit. Now this portion of this board, I'll just go over some of the pieces. We have obviously a transformer, big old transformer sitting here. Here goes your power switch right on the right hand side. Heat seat board, power board, and then your final power amplifier circuitry. And then your main board up here, which is going to be a lot of your preamp components and transistors, potentially to bias whatever input on some of those ICs for controls, several capacitors, etc. I'm giving a little bit of a one-over on this as well as I look through here. We also have, just to see if I can initially notice any issues, we also have essentially springs. Now this came loose as I pulled it out. That's old and double-sided tape per se, a little bit of matting so that way there's not a whole lot of rattling around. But essentially these springs are what's used to create reverberation within the sound. As you increase your reverb, it's going to have an effect to the audio as it's produced, as it's going through a circuit and then outputted to a speaker. So I'm going to have to find a way to get this to stick back down and keep padding underneath it so that there's not a whole lot of vibration external to the intended vibration of those springs. Now as power comes in, it looks like we have two fuses, full wave bridge rectifier via these two diodes. We have some power conditioning. We have a couple voltage regulators. I'm seeing, first off, I believe that's a A1939 PNP power amp. This one over here, now I'll lift this up a little bit. That is a it's kind of harder to read, 669 alpha. I believe that's going to be NPN power transistor, excuse me. That'll be a power transistor. That's a power transistor. Nope, the 669, that's our power transistor. What's this one over here? TIP31C. Okay, forgive me. All right, so TIP31C, TIP31C, those should be PNP transistors. Then we have our A1939. That's going to be a PNP power amplifier. We have a C5196. That is an NPN power amplifier. What else do we have? This guy over here, AN7808. That'll be a voltage regulator for this board. Several transistor types. C224GR. I see those populate everywhere. Those are NPN transistors. I'm seeing a few A1015 PNPs. Also seeing what appears to be transistors, but they're actually PFET MOSFETs, N-channel MOSFETs, J103, and a K30 AGR, as well as some other NPN and PNP transistors and high voltage transistors as well. Especially here, I think that's going to be those in the back there. What are those? 2N5401, that's a PNP high voltage transistor, and a 2N551, that would be an NPN high voltage transistor. Okay, looking over this board. Now I'm not really seeing anything that truly stands out, at least on the top. Capacitor wise, I don't see anything bulging. However, so I knock things off my bench, and I'm seeing something kind of iffy right down in here. I don't know if you noticed that. That is a 100 microfarad 50 volt electrolytic, and it looks like somebody might have been here at one point and tapped a soldering iron onto there, because that looks like some type of solder sticking on the side, and there's an obvious, of course I'm touching it with my pen and getting ink on it, there's an obvious indentation on that capacitor. Maybe that's something I can replace. If I have a spare one, I can go ahead and do that. This capacitor right here, I don't know if you can tell by the camera glare or the light. Of course, if I turn off the light, try to keep it as indirect as possible. There looks to be a little bit of leakage on the top, so we'll mark that. Maybe if I have one for there, it's a potential replacement. Potentially replace that guy. He's kind of loose on the board too, so I'm wondering if he's been replaced once before. Of course you'd say, oh, what's all this down here? That's just glue to help keep these caps secure to the board. But I'm not seeing too many other issues right off the get-go. So I think the next thing we're going to do is I'm going to unhook everything and take these boards out. Okay, so unfortunately I do not have a 100 microfarad 50 volt capacitor. Now I have several at a lower capacitance rating and at 50 volts, but none at 150 volts. But since I don't have that, then I'm just going to leave this as is. Like I said, you know, I'm not, this was a charity work for the church I attend. So if there are items that I don't have on hand directly to fix it at this time, then I'm not going to replace them. And again, the amplifier was working, minus the issues that we uncovered ourselves, minus the 1/4 inch jack up here. So, but at some point in the future, after the pianist continues to use this, if it does break, I can always get those components at that time and come back and replace them. However, one thing that I did want to look at is all of our traces on the back and termination points. I'm not really seeing any broken solder joints, cracked solder joints, any bad termination points. I mean, there are definitely some things where I would have filled in a little bit more, but overall this PCB looks good. You can tell that somebody's worked on this before. With you've still got some older flux on the board. Could be factory, could not, but to me it looks like somebody has worked on this board once before. So I'll go through and just apply a little bit of new flux, not new flux, new solder, lead-based solder to some of these things, just to make them look a little less dull. And we'll throw this board back in. Now this back in and safely secured, I'm going to now work on moving this board out. But in order to do that, I'm going to have to remove all these caps that are on the potentiometers. Ooh, and we got a lot of nuts and bolts and stuff. So I think I'll be doing this, either doing a fast forward section or just completely do this off camera. Okay, again, just taking a look around the board and taking a look at the traces underneath, and I'm not seeing anything overly suspect. You can definitely tell this board has been worked on before, prior. Again, there's quite a bit of flux residue. It looks like components being replaced in the past. Some solder joints look dull versus shiny, so we will definitely touch those up. We'll clean up the board a bit. I'm not seeing any cracked solder joints. Well, I take it back. This one right here for that jack is a bit iffy, so we'll touch up all these. Sorry if you can't see that. I'll see if I can zoom out a little bit more. Let me move this over some. This one right here, and you probably won't be able to tell from the camera. It looks a little bit iffy in there. Maybe over here. We'll touch up those solder joints as well. Spray a little bit of electronic cleaner down in all these potentiometers, give them a few turns to clean them out. I did have a 4.7 microfarad 50 volt capacitor. 4.7 50 volt right here. So I might swap that out. I haven't really decided if I will or not yet. 4.7 microfarad, 50 volt. This one's obviously a smaller form factor than the old one. A lot of Japanese parts. See several op amps, operational amplifiers. 4558 DD JRC. These are dual operation amplifiers. 3 there, 1 here. Let's see, got another one here, here and here. And what do we have right here? 022D JRC. That's an op amp. Looks like we might have some what is this? BL3102. So that's a CMOS. Clock generator driver of sorts. It makes sense because we're over in the speed for the chorus, depth, and reverb section, although reverb is probably that op amp right there. I don't know. We also have a BL3207. That is a BBD, low voltage BBD, also known as a bucket bridge device. That's with our speed. It's probably creating a delay line between the CMOS and this one over here for the speed of our chorus. And then we have over here not just a dual operation amplifier, but a CA30A Echo, which is an operational transconductance, one or the other amplifier. Of course, that's for the master volume. You hear kids in the other room, they're all in the living room playing and getting loud, so it is what it is. So obviously we have quite a bit of pre-amplification on this board before power amplification in the back. I'd be questioning if a couple of these dual operational amplifiers, especially towards the treble adjustment, are starting to go bad, or maybe whatever transistor is there as well. That could be why we're getting a flattening characteristic when we increase amplitude on that signal. A bit of audio cutout there. So that's everything we got on the board. So what I'm going to do is I'm going to touch up these soldering joints. More than likely replace that one capacitor. I don't have any of these op amps or these transistors here. As a matter of fact, the only transistors I have in my office are the 2 high power PNP and NPNs on the power supply board and power amplifier / power amplifier board. Yeah, so that's what we'll do. We'll clean everything out. We'll touch up the soldering joints. We'll replace this one cap, and then we'll see how everything functions. Put it back together and see how everything functions afterwards. Okay, so we got this guy back together a bit. Good enough to perform some retests on it, and I'd like to do that. Some of those previous tests that we had done, just see if anything significantly has changed. But I wanted to show you a cool little new gizmo that I've gotten. I've got this, I went ahead and procured an arbitrary waveform generator. This is a Coolertron CJDS98. Got it off of Amazon. I think it's good up to 60 or 80 megahertz, which is perfect for the AM range of radio frequencies, radio receivers, because I can get everything through the kilohertz range, which is the band that AM radios operate in. Not so much for the FM range though, as those frequencies are in the higher megahertz band. So one of the things I just want to show you real quick is I've got a 1 kHz signal currently being supplied out of this generator at 500 millivolts peak to peak. And then you can see it over here on my oscope. That 1 kHz signal. If I go to my measurements menu and turn on voltage, it's in about 512, 520 volts peak to peak, slightly above what I've input to actually generate. But one of the cool things I want to show you about this, and why it's so important that I got this, and the reason why I bought it, is because I can actually produce a modulated signal. So let's go to something that would probably be in the AM band, frequency 90 kilohertz. Okay, and we see that corresponding change over here. Then if I change my spin per division, you can see that sine wave. It's fairly accurate, 89.99 kHz. Of course, if I put my cursors up, I could probably get a more accurate measurement. I'm going to zoom back out. Alright. So here goes that entire sine wave squished together. And I did that for a second to show you something. Through AM radios, they're amplitude modulated, hence AM. And so we're going to turn modulation on. 500 Hertz at a depth of 80% is fine. But now you can see that corresponding change over here. So we're seeing that nice modulated signal. Then as I expand out, you have that 90 kHz sine wave. Come back in, and now it's modulated. Why do I like that? Well, one, because now I can start working on AM radios, and to an extent FM radios at least. I could do some stuff with the intermediate frequency. But so basically, when you have a RF signal coming in, it's kind of the easiest way for me to explain this is step down to a smaller modulated signal called an intermediate frequency. Most IFs, and I believe, are 10.7 megahertz. Unless you have a dual stage IF receiver for better fidelity. At least that's what is claimed. That first stage would be at 20.6 megahertz, second stage 10.7. But essentially, and I can go into a bit of AM modulation for you, but AM modulation is essentially you take your 90 kHz signal, okay, and then through heterodyning, you're going to apply your intelligence frequency to that signal and affect the amplitude of it. So essentially, if you have a 90 kHz signal, you heterodyne it with a 500 hertz signal, that intelligent frequency will ride the upper and lower portions of your signal and modulate it. So if I span back out and actually turn back on modulation, again, this is a 500 hertz frequency that's modulating that 90 kHz frequency. I lost my train of thought for a second. If I was to take a measurement from center of this modulated frequency to the peak up here and the peak down here, you would find that there is a 1 kHz difference between the center of the frequency to the peaks. And then from peak to peak, you're looking at 2 kHz. Essentially, that's the bandwidth of your signal, 2 times the highest modulated frequency. Wouldn't be 2 kHz, excuse me, because I'm modulating with a 500 hertz frequency. If I measured from center to peak and center to peak, you'd see 500 hertz, okay? And 2 times 500 hertz would be 1000 hertz. So the bandwidth of this frequency would be 1 kHz. Additionally, there's a way to calculate out modulation of this signal. I'm trying to remember off the top of my head, something like Emax plus Emin over Emax minus Emin, or vice versa. Gives you a percentage, you times it by 100. But basically, you're taking the maximum bandwidth from here versus the minimum bandwidth from here. You're adding, you're subtracting, you're dividing those numbers, and then you multiply it out, and that should equal the depth of modulation that you're producing. So those are things that you can test out when it comes to AM modulation. But anyhow, okay, we're gonna start out with some of the same original values that we originally tested at. 65 hertz. Okay. And I'm gonna adjust our main preamp voltage to what we have. What was it at? 240 millivolts RMS. There we go. All right. Oh no, that would have been its center, so I actually need to drop this down. Just want to get something close to our original. All right, there we go. 240 millivolts RMS. We got 65 kHz, 65 hertz signal being fed through. I have my base potentiometer set at 0. We're going to go counterclockwise to the -15 position. Look at that. And we're getting the same value, 40 millivolts. That came to about, slightly over 15 dB of loss. That's good. So base is still good. Let's go to the positive side. I think we were slightly low on positive. Oh, what was it? 1.2 volts. Let's see what happens as we increase. Ooh. Hey. Oh, what am I doing? There we go. Yeah, it's still cutting back. You can actually hear it's distorting that signal. But oh no, I'm turning the wrong thing. Let's disregard that, and I will go back. Overdriving that circuit. Normalize it out back to 240. Yeah, super silly of me. There we go. All right. Now let's go up to 15. We got 1 volt, 1.2, and it backs down again. So yeah, still not quite 15 on the upper end. That pot's probably worn out. Okay, so let's go to the equalizer function. Or excuse me, mid-range. And mid-range we add at 1 kHz. Frequency 1 kilohertz. I'm gonna set that RMS up to, well, first off, before I bump that up, let's see if we are still on frequency. So I'm going to turn up the gain for the mid-range 1 kHz just a little bit, and we will go counterclockwise to see if it increases at all. And it does. So about right there, just as before. That's where 1 kHz is at. I'll go ahead and set this back to 0. We'll get our RMS voltage up to 240 millivolts again. Do the same test. All right, counterclockwise. You get down to 40 millivolts. It's definitely a 15 dB loss. Let's turn it up. Still having that same issue on the upper side. You can actually hear it come through overdriving the circuit. I don't know if you heard that at all. It's probably coming off that coil in there before heading out to the speaker. At least the sound is resonating somewhere. And then our upper range, what did we do? 10 kilohertz. Although, wait a second, were we over 80? I think the previous, let me get that back up to 240. So previously we only got up to 880 millivolts. I think we were higher that time. Yeah, we're slightly better. 1.4, or excuse me, we're up to 1 volt RMS now.
Hey, Daddy.
Hey, bud, hold on 1 second, okay? Okay, son has some questions for me, as kids typically do. Alright, now it's time for the upper frequency. We're going to change to 10 kilohertz. Did I do it? I think I pressed the wrong thing. Frequency. Yeah. Oh, we need to turn that down. That's still way overdriven right at the get-go. I gotta turn this potentiometer down. So I'm wondering, and look, I don't even have this set to 0. Let me turn that way down to 240. Millivolts again. All right, now I got that to 0. Right, set to 0 right there, center. Let's go counterclockwise, and I suspect, yeah, I mean, we had some issues. There's a dead spot in that potentiometer. Because before I go fully counterclockwise, it's 80, 70, 60, 50, 48, so that's almost 15 dB of loss. But and there goes 40, so I definitely over 15 now. 32. Okay, so counterclockwise is good. Still got over 15 dB of loss. What about the high side? Is it going to start clipping again? I'm going to assume yes. And I might be mistaken. So it appears that we've corrected that clipping, but again, the previous measurement was at 1 volt RMS, wasn't it? 1.2 volts RMS was the baseline. So when I had this on 0, we're at 1.2 volts RMS right here. And as I went counterclockwise, I had my, it doesn't even really attenuate when it's that high. Obviously there's clipping. So there might be something internal to the amplifier. If your volume knob for your guitar is turned up, because that is a higher frequency, it might damage the speaker, so it might clip in order that audio to keep from continuous amplitude increase. Or there could be something actually wrong inside of here. Again, I do not have a clue because I have no schematics, but in my head, I think just with what I'm observing, there are definitely some issues, especially with the circuitry here. Hey, if any of y'all know where I can get a schematic for this thing, maybe a servicing manual, if you happen to find one, let me know down there in the comments. I couldn't find one, but I'd be happy to take it in case I have to ever come back in here. But primarily, this is fixed. We gave it a little bit of a service. We had a little bit of change to our mid-level by simply resoldering some junctions. We changed out that capacitor that was in line with that circuit. It had a positive effect on it. I suspect that this capacitor back here still needs to be changed, but this is kind of how it was set up, used with the piano. So I don't imagine that they're going to be turning up, treble is actually right there. I don't imagine that they're going to be turning it up any higher or anything. It's operating. So unless if it has a catastrophic failure, I won't be doing anything else to this, and I definitely don't have the components currently to do anything else. So if it happens to break more, then at that time I kind of know what's going on with the board now, kind of know what components I'm looking at. As a matter of fact, I've now written them all down and we'll tape them inside the chassis there. as well as what I suspect to be bad. And we'll button it up and close out this video. That's all we have time for the final part to this video. You know, like I stated in the beginning, didn't plan on doing a video on this, but figured I'd do one anyways. And for me, that serves as a bit of a point in history in which I can refer back to if I ever see this specific guitar amplifier again for more work, or say if somebody ever reaches out to me with a similar amplifier looking for work. At least I have a reference point on some things to go back and look at. And as I mentioned, a parts listing and some other items. But I kind of want to, now that I've had some time, to consider everything that was tested and the parts. And, you know, oftentimes when I'm trying to present some material and using my hands and making adjustments and stuff, my thoughts don't necessarily connect with what I really want to portray. But now that I have some time to really think about things, I think this would be my, if I can present it this way, a game plan of how I would move forward on those repairs if I ever needed to work on that amplifier again. First obvious things, the 50 volt 100 microfarad capacitors on the power supply. Obvious damage with a soldering iron or something to one. I would replace them both at the same microfarad rating, preferably at 50 volts. Could go a little bit higher on the voltage, although I tried to keep it as close as possible to what is physically on the board concerning the voltage rating. Definitely would not go below 50 volts on that part. So that would be on the power supply slash power amplifier board, if I can term it that way. I don't know exactly what it's called, but that's what I assume is the correct term for it, or the one I'm going to give it regardless. With that being said, I would then move on to what I'll call the preamp slash audio board, where all the potentiometers sit and your op amps, etc. Well, first obvious thing that we saw was bass, mid, and treble. Not much adjustment you have, at least not up to 15 dB increase in amplitude on those levels from that zero reference on the dial. Bass, I think, was just under 14 dB, or right at 14. Our mid was around 11.2 dB of increase, albeit when we replaced that one 4.7 microfarad 50 volt capacitor, we saw an increase up to about 12.3 dB. So that gives us a little bit of a starting point on how to tackle those issues. And then on the treble side, extremely less increase as well as clipping of the audio circuitry. So if I was to, without a proper schematic or sitting down and trying to write out my own diagram of this board, I think a full recap on the preamp board would be beneficial. We would definitely, in my opinion, would probably see a 15 dB increase on once we turn those pots from 0 to positive 15. I think that will rectify a lot of those audio issues. However, that doesn't mean that it will rectify every audio issue we saw. Obviously, when it came to the mid-range, you had a frequency select knob, and on the dial, 1 kHz was not actually 1 kHz. 1 kHz was actually showing up counterclockwise on that dial. Now, I didn't take a volt ohm meter to that potentiometer, which would have been good to test to see if there was any dead spots in that carbon track that would be inside the potentiometer. because that could be a reason as to why it's so far off on the dial. Obviously, impedance of that circuit is very important to what frequency you are selecting on the dial. So more than likely that potentiometer needs to be replaced. At least that's where my current thoughts are at. And then that leads us to the clipping we saw on the treble side, the higher frequency side. Now again, I'm willing to believe to an extent frequencies at that high of a range probably have some type of cutback built into the circuits. That way you're not providing too much amplification, depending on the higher end of the higher side of the frequency that can be processed and reproduced at the speaker. I can imagine higher frequencies can cause damage if they are over amplified, just like any other frequency really, but higher frequencies will probably be more of an issue. However, when we looked at bass and mid-range and treble, we saw with the same, and we saw this with both the arbitrary waveform generator and my phone when I was using it, with the same input level, meaning no matter what the frequency was I was injecting, the voltage of that frequency did not change. At the bass and mid-range, we were measuring, while they were 0 on the dial, somewhere in, millivolt range. Okay, and then we set it for about 240 millivolts to be our nominal voltage under these tests. However, at 0 on the dial for treble, we were right off the get-go not in the millivolt range, but in the actual volt range. So that kind of tells me that maybe there's a bad transistor somewhere causing a little bit of maybe something's being biased, something's being provided a bias or overdriving with no input voltage change. That to me is an issue. I think that there is a specific circuit issue there, whether it's a transistor or related to one of those op amps. Something to look in a little bit further there. But that is how I would proceed forward on these boards. Obviously there's a good demographic of subscribers to this channel, so if anybody has any additional familiarization, this is the first time I've opened up a guitar amp and worked on one, then give me your thoughts in the comments down below. More than willing to listen to them. Above all else, I appreciate your time. Thank you for viewing. If you found this video enjoyable, consider subscribing to this channel, giving the video a thumbs up, and then share if you want to share. Again, none of that ever required, but always appreciated. Take care. Bye.